All right, up till this point, everything we've done in terms of graphing has been with a leading coefficient of 1, okay? Or -1. Obviously, that's not the case. Most polynomials have different numbers than just 1 or -1. So now we're going to start looking at those and how to calculate the leading coefficient. So here's our graph here. We've got x-intercepts at -1, 0, and 3. And it passes through the point. So this is the key. When they tell you a point it passes through, they're saying find the leading coefficient, like the actual number. All right. So the first step is to write it in factored form. So if we have an x plus 1 for the -1, if it goes through the origin, we know that's just x. And if it goes through 3, it's x minus 3. There's no tangents, no points of inflection, anything like that. And then we put this c here to represent the leading coefficient. That's what we're trying to find. Okay? So when you are told a point, find C, the leading coefficient. That's the trick, is when I give you a point, I'm saying, tell me what C is. What is the actual leading coefficient if I don't say that? So of these 2 points, 2, -24, which one represents x? 2, x is always first, right? That's x, y. So all you do, plug it into x and y in the equation. Every x becomes 2, and the p of x, which represents y, becomes -24. So we get -24 is equal to c times x, which is 2. 2 plus 1, 2 minus 3. C, 2, 2 plus 1 is 3. 2 minus 3 is -1. So I get -6c on the right side. So when you divide that off, you get 4. So your leading coefficient is 4. So the actual equation of this graph, p of x, is 4x, x plus 1, x minus 3. Don't expand it. I'm going to assume you can multiply binomials together, whether that's a correct or the wrong assumption. Yeah. Okay, so that's the proper factored form with the leading coefficient in there, not just assuming it's 1. Is that okay? Good? Okay. Here's our graph. We know the x-intercepts. It doesn't tell us a point it goes through. However, it goes directly to this point right here. So what is the value of that point? These are going 5, 10, 15, 20. They're going up by 4s, right? 4, 8, 12, 16, 20. So this point right here is 0 and -8. Does everybody see that? Sometimes they won't just tell you a point, but on the graph, you'll see that you know the actual y-intercept. All right, what is the general factored form of this? It's going to be C, the leading coefficient we're trying to solve. What do I write for -2 x-intercept there? What is the factor of that? X plus 2. What is happening at that point? It's a point of inflection. So it has to have a multiplicity of 3. When you get these types of questions, unless I specify what the degree of the whole function is, assume the lowest multiplicity. Okay? So it has to be a 3. What about this positive 2? What am I going to write for that? X minus 2 to the power of 1, because it just goes straight through. Okay. Now we plug in our x and our y from the y-intercept here, and we solve. So we get negative 8 is equal to c. If I put 0 in for x, I just end up with 2 cubed times negative 2. What's 2 cubed? 8 times negative 2, which is negative 16. Divide it off, I get positive 1/2. Negative 8 over negative 16. Are we good with that? So the actual equation of this function is 1/2 x plus 2 cubed, x minus 2. Yeah? Okay. Now everybody's favorite words. So we're going to have to read this and convert all these words into some mathematical stuff. Determine the equation in factored form of a fourth degree polynomial passes through the point 1 and negative 2, negative 12, telling you the point. Okay, so there's our x and y. And is tangent. What does tangent mean? Sorry, it bounces off, but what does that mean in terms of multiplicities? It has to be 2. So multiplicity equals 2. It's tangent at the x-axis at the point 2, 0 and negative 3, 0. What do those numbers represent? X-intercepts, yes, because y is 0. If you want a visual of this, you have x-intercepts at negative 3 and 2. And it's either bouncing up or it's bouncing down. We don't know yet because we don't know what the leading coefficient is, so we can't actually sketch the graph. Okay, but there's bounces happening there. So we go, okay, our polynomial, we're going to find our leading coefficient, so we put c. At 2, it would be x minus 2 to the power of 2, and at negative 3, it would be x plus 3 to the power of 2. That's our general form of the equation. What do I do now? Plug in your x, y. So I get negative 12 is equal to c, 1 minus 2 squared, 1 plus 3 squared, negative 1 squared, 4 squared, 16. Divide it off. Reduce it, so negative 3/4. So the actual equation is p of x is negative 3/4 x minus 2 squared x plus 3 all squared. So does the graph face up or down? Faces down because we have a negative leading coefficient, right? So if I asked you to sketch the graph, it would look like this. Both arms would be down. It didn't ask for that, but good practice. Okay, is that okay? All right. One little thing after this, but I just want you to do a couple of these. Let's do 1 to 4, please. and then we will do the last bit of this lesson. So now they're going to give us all the x-intercepts. They give us a point it passes through. And the main difference here is one, we have a fractional x-intercept. And then they tell us we only want integral linear factors, i.e. no fractions. So I can't have, so when you're writing this, you're going to write this in the factored form. We're trying to find the leading coefficient because they tell us the point we go through. So we'll just put our C in. If we have an x-intercept of -1, what factor does that look like? What are the brackets? X plus 1. If we have a factor of 0, what do I write for the, or sorry, an x-intercept of 0, what do I write for the factored form? Just x. You could write x minus 0, but that doesn't really make any sense. We just put an x. We have a x-intercept of 3/2. We can write that. We'll talk about that in a sec here. And if we have 2, x minus 2. Now, when they say no integral, or sorry, only integral linear factors, no fractions, they don't want this. So fix it right away. There's two ways to do this. You can fix it right away or you can fix it at the end. If you fix it right away, you don't deal with fractions. If you fix it at the end, you got to deal with fractions. So what do you want to do? Okay. So how do I rewrite this so that I get the same x-intercept? 2x minus 3, right? So that's all you do. You just rewrite that as 2x minus 3. I'm just going to put the x at the beginning because that's the convention. So it's C and x. There you go. So now we have this. And now it's just like the other problems. Okay? They haven't said anything about multiplicities. So they're all multiplicities of 1. They have said it's a 4th degree. And if you check, x times x times x times x is going to give you a 4th degree polynomial. So we're good. What do I do now to solve for C? Just plug in your point like we just did on those questions before. So 2 is equal to C times 1. 1 plus 1 is 2. 2 times 1 is 2, minus 3 is -1. Which gives me 2 is equal to 2C. So what does C equal? 1, which is very anticlimactic. Okay, so the proper form of this polynomial would just be x plus 1, 2x minus 3, x minus 2. There you go. Done. All right. One more question, then we're done. Are there any... Is that clear? It's just what we did on the previous ones, except now they just give us the zeros, and we just have to write it in factored form and make sure there's no fractional factors. All right. Now we've got multiplicities involved. So we have 3 roots. We have a -2 as a root. Remember, roots, x-intercepts, and zeros are all the same number. So if I say a root, I'm really talking about an x-intercept. -2 is an x-intercept with a multiplicity of 1. So that means it's like that, right? That's the factored form of it. 1/3 is a root with a multiplicity of 2. So you would write, that's a 3, like that. But how do I write it without a fraction? 3x minus 1. All squared still, because it has a multiplicity of 2. And 1 is a root with a multiplicity of 3, so that's x minus 1 cubed. And then it doesn't look like they give you a point, but they do tell us that we have a y-intercept of 2/3. What's the value of x at the y-intercept? 0. So that means we actually do know a point. We know the point 0 and 2/3. All right. So we write out our general factored form. C x plus 2, 3x minus 1, x minus 1 cubed. Plug in our x, y points and solve it. What's my answer? What do I do with this -2? Divide it off. So if I divide by -2, how do you divide fractions? You flip the bottom and multiply, right? And -2 is the same as -2/1. So it's 2/3 times -1/2. Those cancel, and you're left with -1/3 is equal to c. So the proper form is -1/3 x plus 2, 3x minus 1 squared, x minus 1 cubed. And there you go. Are there any questions about that? All right, 7 and 8, please. And that is it for today.